44. A particle moves along the x-axis so that its acceleration at any time t is greater than or equal to 0 is given by a of t equals 4t squared times the square root of t plus 3. If the velocity at time t equals 7 is 4.326, what is the speed of the particle at time t equals 0? So let's look this over. I'm given the acceleration function. I have the initial condition that at time t equals 0, the velocity is 4.326. And I'm looking for the speed. That's going to be very important. Speed is like velocity, but not exactly the same at t equals 0. Okay, so what I should know is this. The change in velocity, the delta v, will be equal to the integral, and I'm going to care about times 0 and 7, so let me put that in there right now, from 0 to 7 of the acceleration, a of t, dt. And so if this is the change in t, or change in v, I can write out my equation now saying that, alright, the ending velocity, v at time 7, will equal the starting velocity at time 0 plus my delta v, change in velocity. So v of 7 will equal my starting velocity plus the integral from 0 to 7 of my acceleration with respect to t. And now I want to actually solve for the speed of the particle at time t equals 0. So I'm going to start finding the velocity. So I'm going to isolate this velocity. So I'll subtract this integral from both sides and get that v of 7 minus the integral from 0 to 7 of a of t dt is equal to velocity at time 0. And now let's bring in the information that we have. So first thing, the velocity at time 7, the v of 7, will be equal to 4.326. Minus. We have the acceleration function right here, so I'll use that instead of a of t now. So the integral from 0 to 7 of 4t squared times the square root of t plus 3 dt. And that's going to end up equaling almost what I'm looking for. It could actually be equal to it, but we're going to have to find that out at the end. And I look at this, and 4.326, that's a decimal, whatever. But the integral of 4t squared times the square root of t plus 3, and u substitution won't work. I could try integration by parts, but really when it comes down to it, this function, just put in the calculator. We have numerical solutions anyway, so let's put that in and we'll see what we get out. So go to our handy calculator, math, scroll down to the, or actually before I do that, let me put in the entire thing. So we have 4.326 minus the fn int, which is going to be 9 on the list. I haven't scrolled down a little bit. Let's scroll down and see. There it is. Fn int. My function is 4, and I'm going to put x's in because they're easier to type. 4x squared times the square root of x plus 3. Close that off. dt, so I'll put dx here as we go from 0 to 7. Close off the parentheses. Okay, 4x squared, 4t squared times the square root of x plus 3. All right, and press enter, and by a little calculator magic, I get negative 1,304.361. So we look and say, hey, so negative, let me go back to this. So I'm getting that v of 0 is approximately negative 1304.361. Like, hey, C, no, that's not right. Last thing here. Don't forget we're looking for speed. and the speed is equal to the absolute value of the velocity. So in our case, it's actually going to be the absolute value of negative 1304.361. Little tricky part there they put in there, just try to fool you. And the absolute value, of course, makes this positive, 1304.361. So my answer is actually E.